in chemical energetics. Reactions. What are exothermic? What are endothermic reactions? Their examples, enthalpy changes, their profile diagrams, what is activation energy. So these are all things we are going to discuss. So the first topic is exothermic reaction. So as the name suggests, exo means out. Okay. Exo means out. So exo means out. That means it is a reaction which transfers heat energy to the surroundings. That means it releases heat energy to the surroundings, are known as exothermic reactions. So what happens? What is the surrounding? Surrounding means there are two terms involved here in this chapter. One is system and one is surrounding. System is that thing in which we are doing our reaction. Okay. For example, if you are doing any reaction in a test tube, so that is a system. Okay, the place where you are doing the reaction, and the other thing is your surroundings. The entire universe is your surroundings. So system plus surrounding makes up your universe. So in an exothermic reaction, temperature of surrounding means apart from the system, leaving the system, everything is surrounding. So it releases heat energy, so temperature of surrounding will increase. Now let us look at this with the help of an example of what we do in the chemistry lab. When magnesium it reacts with sulfuric acid in a test tube, then this is an exothermic reaction. That means energy released, it is transferred to the surroundings, and you can see that the test tube will become hot. Temperature of the reaction mixture in the tube increases. Okay, so by touching the test tube, we can make sure that this is an exothermic reaction because heat is released. So this reaction, that magnesium when reacts with sulfuric acid to form magnesium sulfate plus hydrogen gas, it is your exothermic reaction. Is it clear what is an exothermic reaction?
Yes.
You want to write it down?
Yeah.
Write it. The next reaction is your endothermic reaction. So endo means in. That means heat energy is coming inside. So the chemical reactions which absorb heat energy from the surroundings, they are known as endothermic reactions. So in exothermic reactions, they are releasing heat energy to the surrounding. In endothermic reactions, they are absorbing heat energy from the surrounding. So temperature of the surrounding, it will decrease because the system is absorbing the heat energy from surrounding. So temperature of surrounding will decrease. Example is when sodium hydrogen carbonate reacts with an aqueous solution of citric acid in a test tube, then you will see that temperature of the reaction mixture in the tube decreases. The test tube will become cold. Why? Because citric acid and sodium hydrogen carbonate, they are absorbing the heat energy from the solvent, the test tube, and the air. That means from the surrounding. Solvent, test tube, and air, it is your surrounding. So they are absorbing the heat energy, right? So it will become cooler. The test tube will become cooler. So it is your endothermic reactions. Okay, examples of endothermic reactions. So we have, you might have seen that in to treat sports injury, we use the cooling pack. When you rub or press the pack, then the water and ammonium chloride crystals mix. This is your endothermic reaction. So as the crystals dissolve, energy is transferred from the surroundings and it will cool the injury. So you can use a cooling pack to treat a sports injury. Examples of endothermic reactions include the decomposition of limestone by heating. Limestone is calcium carbonate. So when you decompose it, you get calcium oxide plus CO2. So energy is absorbed in this reaction. That's why it is endothermic reaction. Even all the thermal decomposition reactions are endothermic. Photosynthesis is endothermic reaction because energy is absorbed by plants, okay, by sunlight. Energy is supplied by the sunlight. Dissolving certain ammonium salts in water. When you dissolve ammonium chloride in water, you have ammonium ions and chloride ions. So when you dissolve certain ammonium salts in water, energy is required. Okay, so it is also your endothermic reaction. Write it down. Okay, now enthalpy changes. So what is an enthalpy change? It is just the energy exchange between a chemical reaction and its surrounding at constant pressure. This is important. At constant pressure, it is called an enthalpy change. Its symbol is H. We cannot measure the enthalpy, but we can measure an enthalpy change. You cannot calculate the absolute value of enthalpy, so you calculate the change in enthalpy, that is delta H. Okay, so this is your enthalpy change. How to calculate enthalpy change? Enthalpy of products minus enthalpy of reactants. So you can calculate the enthalpy change. What is the unit of enthalpy change? It is kilojoules per mole. Okay, the unit for enthalpy change is kilojoules per mole. Why you cannot calculate that solution?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Value of enthalpy, because it is equal to the sum of internal energy and sum of internal energy and the pressure volume curve. And internal energy is everything, every energy inside it. You cannot calculate the absolute value of internal energy, that is U. So if you cannot calculate the absolute value of internal energy, that's why you cannot calculate the absolute value of enthalpy. So you always calculate it in terms of change. And the formula for it is enthalpy of products minus enthalpy of reactants. Okay, so what is an enthalpy change? It is just the energy exchange between chemical reaction and its surrounding at constant pressure. The pressure should be constant in enthalpy. So it is known as enthalpy change. Clear? We'll do numericals based on this.
Okay.
Okay, so this is the enthalpy profile diagram. So the x-axis, it will represent your reaction pathway. That means how the reaction is moving. And the y-axis, it represents your enthalpy of enthalpy. Okay. So in the case of which reaction? Exothermic reaction. In the case of exothermic reactions, always remember that enthalpy of reactants is greater than enthalpy of products. Okay, so how to remember this? Because we know that enthalpy change is equal to enthalpy of products minus enthalpy of reactants, right? And the value of delta H for exothermic reaction is always negative. So this equation comes negative only when your enthalpy of reactant is greater than enthalpy of product. Okay, so you can remember it by this thing, that in exothermic reactions, enthalpy change is always negative. So we have to make a reaction profile diagram for combustion of methane. Combustion means that your methane, it is reacting with oxygen to form your carbon dioxide and water. You have to balance the equation. So you know that enthalpy of reactants is greater than enthalpy of products. Okay. What is EA? EA means your activation energy. That means the minimum amount of energy which is required for the reactant molecules to collide and form a product is known as activation energy. And what is delta H? Delta H is enthalpy of products minus enthalpy of reactants. Okay, so if you measure the enthalpy at this point and if you measure the enthalpy at this point, you get the value as minus 890.3 kilojoules per mole. Enthalpy we measure in kilojoules per mole. Is it clear? The diagram is clear?
Yes.
This is for exothermic. So draw it for exothermic reaction. So the combustion of methane, it is your exothermic reaction. How to know it is an exothermic reaction? By negative sign of this enthalpy change. If this is negative, it is for exothermic, and if delta H is positive, it is for endothermic. So what is activation energy? Minimum energy that the colliding particles must have for a reaction to happen and to convert it into products is known as activation energy. Now it always have a positive value of delta H, positive value of enthalpy change, because enough energy has to be absorbed to increase the kinetic energy of the reactant molecules so that they will collide with enough force to break the bonds. Okay. So what is activation energy? Minimum energy that colliding particles must have for a reaction to occur and to convert it into products. It is activation energy. Now, what is the sign of activation energy for delta H? It is always positive because energy has to be absorbed to increase the kinetic energy of the reactant molecules so that they will collide faster with enough force to break the bonds and to convert it to products. Okay, copy it. So for an exothermic reaction, energy is released to the surrounding. So enthalpy of reactants must be greater than enthalpy of products. We know that for exothermic reaction, delta H should be negative, right? And the formula to calculate delta H is equal to enthalpy of product minus enthalpy of reactant. So this equation, that means delta H comes negative only when enthalpy of reactants is greater than enthalpy of products. Okay, so we can see from the reaction pathway diagram that enthalpy of products minus reactants is negative. Okay. So this is opposite for in the case of endothermic reaction. energy is absorbed from the surrounding. Okay, so it is enthalpy should be positive in case of endothermic reaction. The formula to calculate is HP minus HR. So this equation comes positive only when HP is greater than HR. That means enthalpy of product, it should be greater than enthalpy of reactant in the case of endothermic reaction. Draw the enthalpy profile diagram for endothermic reaction. For the decomposition of calcium carbonate, this is endothermic reaction. Here you can see that enthalpy of products is greater than enthalpy of reactant. And the activation energy is also larger here in this case. The activation energy, and this is delta H, whose value is positive. Okay, so this reaction is the decomposition of calcium carbonate to calcium oxide plus carbon dioxide. The enthalpy change is positive, that means the reaction is endothermic.